So now that we have the mechanics of solving systems of linear equations down through either the substitution method or the addition method, sometimes called the elimination method, now we are better able to apply that to the word problems. So in the word problem, same as we did in chapter 2, there's always 3 marks for them. There's a mark for the let statement, there's a mark for the equation, in this case the system of equations, and there's a mark for answering the question. So in these ones, for the let statements, you now get the bonus 33%. You get to, if you're looking for 2 different things, you're going to call one thing X and the other thing Y. And that seems to make the let statements way more intuitive for students. You still get a mark for the equations. And like I said, for this chapter, it's more than one, so it's a system of equations. And then you get a mark for the answer. A lot of these word problems are divided up into different kinds of word problems, which helps, again, kind of sort them in your mind. And we're going to really try and pull them back to those same strategies that we used in chapter 2 to build up our answer to these things. In your homework, I have attached a series of word problems to the homework page. So these ones are not pulled out of your textbook. They're directly from the handout that's on the blue paper in your paper package or on the Moodle site. So let's try one of these. The first kind is a number problem. So this one says the sum of 2 numbers is 25 and the second number is 5 less than the first. What are the numbers? Okay, so this is the answer, and I just typed them into the notes there. So we're going to ignore that for now. Maybe this is one that you can figure out intuitively, but let's take a look at this. So the first thing we're going to do is recognize that we're looking for 2 things. So we're going to say let X be one number and let Y be the other. Welcome to 33% worth on your first question here. So these questions are rigged to be a little different than the kinds of questions that we did in chapter 2, in that they give you more information. So there should be enough information in the question for you to translate 2 equations out of this. So the first piece of information is this sentence right here. It says the sum, so that means the addition of the 2 numbers, which we just defined as X and Y, is 25. And so that first equation that we're going to write is X plus Y equals 25. And that's going to be my first equation in my system here. The next sentence is going to give me the information for the next equation. So it says the second number is 5 less than twice the first. So the second number is this Y value. So Y would equal, the second number is 5 less, so that's minus 5, than twice the first. So 2x minus 5. And that gives me that translated equation that is the second equation in my system of equations. So now that I have that, that's the second mark, definitely harder to get and harder to work through. The last little bit of this is to answer the question. So we're going to solve this through either the addition method or the substitution method. Because this one is already got the y variable isolated here, I'm going to use the substitution method. And to be honest, I'm partial to the substitution method. So I'm going to take equation 2 and sub it into equation 1. So rewriting that, I'd have x plus this 2x minus 5, because that's what y is equal to, equals 25. So now I have one variable here. I can just drop the brackets, and I'm just going to use the eraser to do that. Sometimes it matters. In this case, it didn't. Subbing in with brackets is always a good idea. So I'd collect my like terms and get 3x minus 5 equaling 25. I would add 5 to both sides. I'd get that 3x equals 30. Divide by 3, and I get that x equals 10. Now that's only one of my letters. Remember, I'm looking for the two numbers, so I'm looking for x and y. So in this one, I could take that and sub it back into anything. I'm going to take and sub it back into equation 2 because it was already solved for y. So y would equal 2 times 10 minus 5. So that would be 20 minus 5. Y would equal 15. So my final bit is that the numbers are 10 and 15. All right, let's do another one of these number ones. Really, the key to these is that translating bit, which sometimes isn't what people love about them. Okay, so the next one says we've got two numbers, and the sum of those numbers is 28. Okay, well, if I'm looking for two numbers, I'm going to say let x be the first, let y be the second. Okay, so now I've got this translating bit. So the sum of two numbers is 28. So x and y would equal 28, and that's going to be my first equation. My second sentence here gives me more to translate. So it says here the second number, so that's y, is 4 more, so that'd be plus 4, than twice the first. Really similar to that last example that we did. So again, the mechanics of this is what we've already practiced in chapter 8. We know that we can sub equation 2 into equation 1. Oops, I did that backwards. Let's try that again. So where I see the y, I'm going to sub it in. So after all that, I can solve for my one variable, and I'm going to have to chase down the other variable. So I'm going to take and sub that into 2. So now that I have that, I have the answer to my question. I know what the value of x and y is. So the numbers are 8 and 20. The next kind of problem are geometry problems. So similar to the last time that we did geometry problems, we're going to stay with the idea of drawing a picture and using a framework equation. So this one tells me that the length of a rectangle is 3 more than twice the width. And this is the first time you could either do this question chapter 2 style or do this question chapter 8 style. And in all honesty, it doesn't really matter to me. In the notes, I'm going to kind of force us into the chapter 2 style. So if we have a rectangle and I have the powers of two variables, I'm going to say that this is y and this is x. Now this also tells me a few other pieces of information. It tells me that I'm dealing with the perimeter. So that tells me the framework equation. I know that perimeter equals 2w plus 2l. Okay, so in this one, the first piece of information is just giving me my first equation here. So it tells me that the length, y, is 3 more than twice the width. So twice the width plus 3 would be the length. Now, if we had done this chapter 2 style, you would have just labeled that where you saw the y. So if this doesn't sit doing it chapter 8 style, then do it chapter 2 style. It's exactly the same thing. The other piece of information that we have here is that the perimeter of the rectangle is 42. So going back to that framework equation, we'd know that 42 would equal 2 times x plus 2 times y. In this, we have equation 1 and equation 2 crafted. And because equation 1 was solved for that y variable, we could take and sub that into equation 2. So rewriting equation 2, I'd have 42 equals 2x plus 2 times all of that thing that I said is y. Now, if you had not gone along with me in this chapter 8 style, that equation is the one that you would have got with chapter 2 style, right? Chapter 8 is given us the powers to break it apart into two little equations. But in a weird way, we were actually doing the hard stuff first in chapter 2. So again, bottom line on this, doesn't matter to me whether you do it chapter 8 style or do it chapter 2 style, but I think it is important that you have a general understanding that it could be done either way. So taking this equation to solve for x using distributive property first and solving for x. After a bunch of work, I get down to that x equals 6. And again, we're only halfway done. In chapter 2 style, you would have gone back to your picture. You would have gone back to your let statements to figure out the length. But we could say now, take that and sub it into equation 1. So y would equal 2 times 6 plus 3. So we get 12 plus 3 or 15 for y. And so that tells me the dimensions of the rectangle. The dimensions are, what is that? 6 meters by 15 meters. So there's another one down here. Another geometry problem that I am going to do chapter 8 style. You could do it chapter 2 style. So this one is about a triangle and an isosceles triangle specifically. If you're ever in doubt, you're welcome to ask for information about that. So an isosceles triangle is one like the top of a kite where these two sides are the same length and this one would be different. And so that's kind of built into that word isosceles, which we haven't done a lot of geometry in this course. So if that's something you need to, have support in, then that's totally fine. So given that piece of information now, we're given a few more things going on. So it says the length of each of the two equal legs on the isosceles triangle is, so that would be x, right? Because those are the two equal legs, is 5 inches less than the length of the base. So this was the base down here, this y. And so this has given me my first equation, x equals y minus 5. The other piece of information would be that framework equation. And maybe you did this chapter 2 style where you just wrote this expression on the two equal sides here and then use the framework equation. So the framework equation is that the perimeter of a triangle, is side 1 plus side 2 plus side 3. And again, that's your framework equation. As I taught geometry problems before, that's another given piece of information, maybe from your formula sheets. So that tells me that I would have, again, those are the answers, I just got distracted, 50 equals 2x plus y, because that would be the sum of the three sides. If you wrote it out as x plus y, that would be fine. I took it one step further. So now that we have all that information, that defines my system of equations here. If I took and subbed equation 1 into equation 2, you're going to make the equation that if you were doing this chapter 2 style, you would have started with. And so I would rewrite the 50 equaling 2 times all of that x, which is y minus 5, plus y. In doing this, I need to now solve for y. And so I've got a little distributive property to do. I got some collecting of like terms to do. I've got some isolating of variables to do. Whoops. And I got some solving for y to do. Again, that only gives me half of my information, so I'm going to take that value and sub it into equation 1. If you're doing this chapter 2 style, you just sub back into your other let statement, your other expression. But if I take and solve for x now, I get that x equals 15. And so in this one, I mean, the answer here is S's and B's, doesn't really matter. In this one, I would say, answering the question, the lengths of the legs, so the legs are, what is that one? 15 inches, and the base is 20 inches. The videos would get real long if I did these both chapter 2 and chapter 8 style. So if this chapter 8 style is something you're struggling with and you can get to the answers in chapter 2 style, then go for it. But I think it is worthwhile seeing these systems of equations and our process for solving them in action. So another kind of word problem that we did were mixture problems. And in mixture problems, we had that system of sorting things into boxes. And so in these ones, we're going to have that same approach. But when we have that system of sorting into boxes, in the last chapter 2 style, what we did was come up with an equation out of the bottom side here, right? So that was very much chapter 2 style. In chapter 8, what we're going to do is actually craft two separate equations. So chapter 2 style, we're going to have an equation up here, and we're going to have an equation down here. And this would be equation 1, and this would be equation 2. So it's fairly similar, and again, it's going to give us this chance to break our material down so that we can build it back up. All right, so good old Winifred has $4.50 in coins. She has nickels and she has dimes. If she has 55 coins, how many of each kind of coin does she have? So let's sort this out. She has two different kinds of things she's mixing together. So we've got nickels and dimes. She's going to have some amount of a total of these things. So we've got nickels and dimes, and that's going to equal sum total. So as we were sorting these before, this would be the number of things, this would be the value of things. The key difference between chapter 2 and chapter 8 is that when we're looking for two different things, we can call them two different letters. So we're going to call nickels X and dimes Y. Well, the total number of coins is 55. If we were to come up with the value of this, we know that her total value is $4.50. So crafting my equation for the value of this, it would be 0.05, because that's how many cents a nickel is in dollars, right? So 0.05x and 0.10y, because x is representing the number of nickels and y is representing the number of dimes. So like I had said at the top of the page, we're going to craft two equations here. We're going to craft one equation across the top. Whoops, I can't highlight, I'm going to circle it. So one equation across the top here, and one equation across the bottom. So I'm just going to take and rewrite those for us. We'd have, let me just see here. So we'd have x plus y equaling 55, and we'd have 0.05x plus 0.10y equaling 4.50. So this is going to be my equation 1. This is going to be my equation 2. You could solve this through the addition method or the substitution method. I'm going to use the substitution method, which means I have to take my equation 1 and alter it a little bit. I'm going to write it as x equals 55 minus y. And in that, then I could take that and sub that into equation 2. So rewriting my equation 2, I'd have 0.05 times 55 minus y plus 0.10y equaling 4.50. All of that work is amounted to the kind of equation that you would have got in chapter 2 when we were solving these with chapter 2 style. So again, like I said in the geometry, I am less concerned about how you solve these than I am that you have a strategy to solve them. So in this, we're going to solve for y. We're going to use distributive property. So I'd have 2.75 minus 0.05y. Copy the rest of it out. Start with some collecting of like terms. Isolating some variables by subtracting 2.75 on both sides. Maybe some calculator use here. And then finish up by solving for y. So that y equals, what is that, 35. only half of the answer here. I'm going to take and sub that back into, so sub into equation 1. If you're doing this equation or chapter 2 style, then you just go back to your let statements as you remember. So I'm going to sub into 1. So x equals 55 minus that 35, or x equals a 20. So that tells me that she has 20 nickels and 35 dimes. One more mixture problem done in chapter 8 style. So this one I'm going to set up similarly. I'm mixing two different kinds of tickets together. So I'd have $8 tickets and $6 tickets. I know that I'm going to mix them together and make some amount total and some value total. And the way this is different is that I'm going to actually craft two different equations out of my boxes, but I fill them in similarly. So in these ones, I'm going to call the number of $8 tickets X and the number of $6 tickets Y. It says that there are 350 tickets sold in all, and the receipts were 2,500. Usually by this point, people are like, oh, I like this chapter 8 style better, or oh, I like that chapter 2 style better. So however you're feeling on this is absolutely fine. Now that I have that information, I've crafted two equations. So one equation across the top of my boxes and one equation across the bottom. I'm just going to take a minute to write that out. And here you have some choices. You could solve through the addition method, or you could solve through the substitution method. I will be fully transparent. I am absolutely partial to the substitution method. So I'm going to take equation 1 and rearrange it so that x equals 350 minus y, or minus y plus 350, doesn't really matter. And that gives me a chance then to sub that into equation 2. So then I would write 8 times 350 minus y plus 6y equals 2,500. Distributive property to solve for y in this one, I'd have 2,800 minus 8y plus 6y equaling 2,500. I'm going to gather up some like terms here. I'm going to isolate some variables. And I'm going to solve for some y. I end up that y equals 150. Now that gives me half of my answer, so I'm going to chase down the other. I'm going to sub that into 1, into my reorganized 1, if you will. So x would equal 350 minus 150, or x would equal 200. And rolling those two values back into what is my answer, that means that I've got 150 $6 tickets, and I've got 150 $8 tickets. Oh, how did I get that backwards? Oh, sorry, oh my goodness. Okay, I should read my questions. I think I'm mistaken my key there. Okay, so what is it? X is $8 tickets. So let's try this again. So I have 200 $8 tickets, and I have 150 $6 tickets. There we go. One last kind of problem in these, and these are motion problems. So that was a distance, rate, time problem. These ones are slightly different, and there's only one variation of them. There's not like the 4 different scenarios or any of that. All of these are motion problems with a current or with the wind, and then against. So we have this sum of velocities and a difference of velocities. So when you go and rent a paddleboard from Lakeside. I don't know if people are familiar with Nelson. So if you rented a paddleboard from Nelson or from Lakeside and then headed off downstream towards the Prestige, you are going to be traveling with the current. And say it's springtime, you're going to feel like a rock star heading downstream with the current because you're not going just the speed that you can paddleboard, but you're also going with that extra boost of the current of the river. Now, when you turn around at the Prestige and paddle back towards Lakeside, you're going into the current, and that's going to make it feel a whole lot harder. So sometimes people can get in trouble. I know there's lots of signs down along the waterfront, but that's the kind of idea with this. So we've got a boat this time traveling downstream, and then it's going to turn around and come back upstream. That's against the current, and it's going to take it a lot longer. So these are distance, rate, time problems. And we've got this return trip in both cases, but the top part of my chart is going to be with the current, or the bottom part is going to be against the current. So let's see what information we have here. Again, chapter 8 style, we're trying to craft two separate equations. So it says the boat can travel 36 miles downstream, so that's with the current, downstream, in 2 hours. And coming back upstream, the trip, same trip, so same 36 miles, is now going to take 3 hours. So what we're trying to do is find the rate of the boat and the rate of the current. So I'm going to say that x is the rate of the boat and y is the rate of the current. So when you're going downstream with the current, you've got the rate that you can go plus that extra bump of the current speed. When you're going against the current or coming back upstream, that means you're going the rate you can go, but you're losing ground because you're going against the current. And so you put a negative y there. If we remember that distance equals rate times time, what we've done here is crafted one equation across the top. Oops, sorry, I meant to pick the highlighter. I keep picking the highlighter and there's no typing. So here, right, that's one equation, and this is the other equation, remembering that distance equals rate times time. So I'm going to write those out as more clearly obvious equations, and I'm going to write them out that, how will I write it? 36 equals 2 times x plus y, and 36 equals 3 times x minus y. So these are going to take a little bit of work before I can see them as a way that I want to solve them. So I'm going to take and I'm going to distribute. I'm going to write them beside each other. So 36 equals 2x plus 2y, and 36 equals 3x minus 3y. So now that I have these two systems of equation 1, or this one system of equation 1 and equation 2, I can decide how I want to solve it. I could solve through the addition method, or I could solve through the substitution method. In this one, just to kind of be a little bit more diverse, I'm going to pick the addition method, and I'm going to take and multiply this equation by 3, and I'm going to multiply this equation by 2. I'm totally out of space here, so I'm going to continue my work down here. I would actually then have, what is that? 108 equaling 6x plus 6y. And I would have 72 equaling 6x minus 6y. Now that I have these y terms, or these y variables, their coefficients matched but opposites, I can solve through addition or solve through elimination, if that's the way you've thought of it. So in this one, when I add those two together, I would get 180 equaling 12x. The y's go away. That was the point of the game here. So divide by 12, and I get that x equals 15. This x equaling 15, I can take and sub back into any old equation. I'm going to take, just for simplicity, sub it into equation 1. If I can see that one up there, this one up here. So I take and I sub in the 15 where I see the x. So I'd have 36 equaling 2 times 15 plus 2y. I'm now trying to solve for y. Minus 30 on both sides. And I get that 6 equals 2y, or that y equals 3. So all of this tells me what x and y are. So that tells me that the boat goes 15 miles per hour, and the current is either giving you a boost or taking away from your speed at 3 miles per hour. And that's the answer to the question. One last to go through. Similar to this, this is a plane flying into the wind and then returning with the wind. So it's a distance, rate, time question. Again, in chapter 8, we're hoping that we're given enough information that we can craft 2 equations. So this time we're going with the wind in 4 hours, 480 miles. So this is with the wind. And then we're going to go against the wind. So currents, winds, whatever it is. Most people have done this on a bike when you like go on a road bike or something. So against the wind, going to be slower. It's going to take 6 hours. You're still going that same distance. So the idea here is that we're looking for the rate of the plane and we're looking for the rate of the wind. I'm going to call the rate of the plane x and the rate of the wind y. Doesn't matter which you want to call which, but the idea with the wind is that you're getting the boost. It's the sum of those 2 speeds would be your total speed. Against the wind, it's the rate of the plane, but you're losing the speed of the wind because you're fighting against it. So this is going to create 2 equations. I might write them a little bit differently than I did last time. I always feel a little awkward when the number's sticking out the front here. So it might be that 4 times x plus y equals 480, and 6 times x minus y equals 480. I'm going to make this look a little more sensible in that 4x plus 4y equals 480, and 6x minus 6y equals 480. In this one, I could use the substitution method or I could use the addition method. I'm going to use the addition method on these ones just because I am prone to using the substitution method. I'm going to call that equation 1 and I'm going to call that equation 2. What I'm trying to do is match the coefficients, and I'm going to focus on these y variables because I see that one's positive and one's negative. So I'm going to take this first equation, I'm going to multiply it by, let's say, 3. To get to 12 on my y variable. I'm going to take the second equation and multiply it by 2 to get to 12 on my y variable. You could have multiplied the top one by 6 and the bottom one by 4. You just would have had bigger numbers. And so in this, I'm going to rewrite these. I'd have 12x plus 12y equaling 480 times 3, which is 1440. And then I'd have 12x minus 12y equaling, what's that? 960. So now that I have those y variables, their coefficients matched and opposite, I'm going to solve through addition here. I'd have 24x equaling whatever the heck that is, 2400. Divide by 24, divide by 24. I'd get that x equals 100. And then I need to chase down what my y is worth, and I can choose any equation to go back into. So I'm going to take that and I'm going to sub that into equation 1 as I had it way up here, right? That's my equation 1, or my original equation 1. You could have gone all the way back to the beginning. It doesn't really matter. You should get the same answer regardless. But I'm going to rewrite equation 1 subbing 100 in for where I see the x. So I get 400 plus 4y equaling 480. Subtract 400 on both sides. 4y equals 80. And then divide by 4, divide by 4. So I get that y equals 20. And so all of this tells me that the plane goes 100 miles an hour and the wind is going 20 miles per hour. So there are a lot of those application questions in your homework. Like I said, give those a try. I think, again, it's the process in this. It's not just the mechanics, but it's breaking them down and then building them back up. So that does chapter 8 and really finishes this section of linear equations. The next chapter up will be chapter 9.